Alright, so in this problem, I have a to the power of x plus 2 to the power of x is equal to 130. So to solve this, I'm going to first start by rewriting a as 2 to the power of 3. So now I have 2 to the power of 3 to the power of x plus 2 to the power of x is equal to 130. And I can actually switch the places of 3 and x. So this is the same thing as 2 to the power of x to the power of 3 plus 2 to the power of x is equal to 130. Now I'm going to let 2 to the power of x equal to the variable y. So now I have y to the power of 3 plus y is equal to 130. Now I'm going to subtract 130 on both sides. These two cancel out. So now I have y to the power of 3 plus y minus 130 is equal to 0. Now I'm going to rewrite y here as negative 25y plus 26y. Now I have this minus 130 is equal to 0. And now y to the power of 3 minus 25y, the greatest common factor is y. So I get y times y squared minus 25 plus 26, y minus 130, the greatest common factor is 26. So I get 26 times y minus 5 is equal to 0. And y squared minus 25, that's the same thing as y plus 5 times y minus 5. And now if I factor out y minus 5, I get y minus 5 times y times y plus 5 plus 26 is equal to 0. So now this gives me two equations. I have y minus 5 is equal to 0, which means y equals 5, and I have y squared plus 5y plus 26 is equal to 0. And to solve this, we actually have to use the quadratic formula, and I'm not going to waste your guys' time by doing it, but if you do end up doing it, it actually won't work because you get the square root of a negative number, and you can't take the square root of a negative number. So we are left with y equals 5, and remember how we let 2 to the power of x equal to y. So this means that 2 to the power of x is equal to 5. And I'm going to take the log on both sides to solve this. So I have log 2 to the power of x is equal to log 5. And if I have something in the form log a to the power of b, I can move this exponent to the front, so it's going to equal b times log a. So this is the same thing as x times log 2 is equal to log 5, meaning x is equal to log 5 over log 2. Alright, so in this problem, I have 2 to the power of x is equal to 3 to the power of x. So I obviously want to find the value of x here. So for my solution, I'm going to first start by writing 2 to the power of x is equal to 3 to the power of x. And I'm going to take the log of base 2 on both sides. So now I have log base 2 of 2 to the power of x is equal to log base 2 of 3 to the power of x. Now, if I have something in the form log base a of a, this is simply equal to 1. So as you see here, we have log base 2 of 2. And actually before I cancel these two out, if I have something in the form log base a of to the power of b, I can move this exponent b to the front. So it's going to equal b times log a. So in this case, I have x as my exponent, so I can move this to the front. So now I have x times log base 2 of 2 is equal to, I'm going to do the same thing over here, log base 2 of 3 to the power of x. I can move x to the front here. So now I have this is equal to x times log base 2 of 3. Now remember, if I have something in the form log base a of a, this is equal to 1. So log base 2 of 2, these two cancel out, so I get simply left with x times 1 is equal to x times log base 2 of 3. And x times 1 is simply x, so I get x is equal to x times log base 2 of 3. Now, I'm going to subtract both sides by x log base 2 of 3. So these two cancel out. I get x minus x times log base 2 of 3 is equal to 0. Now if I factor out x, I get x times 1 minus log base 2 of 3 is equal to 0. And if I divide both sides by 1 minus log base 2 of 3, these two cancel out, and I'm left with x is equal to 0. Alright, so in this problem, I have 9 to the power of x is equal to x to the power of 6. Now I'm going to find the value of x. So for my solution, start with 9 to the power of x is equal to x to the power of 6. And I'm actually going to take the power of 1 over x on both sides. So now I have 9 to the power of x to the power of 1 over x is equal to x to the power of 6 to the power of 1 over x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 9 to the power of x to the power of 1 over x, that's going to equal 9 to the power of x times 1 over x. And x to the power of 6 to the power of 1 over x, that's going to equal x to the power of 6 times 1 over x. Now x times 1 over x, these two cancel out, so it's just, I'm simply left with 9, is equal to 6 times 1 over x, which is 6 over x. Now I'm going to take the power of 1 over 6 on both sides. So now I have 9 to the power of 1 over 6 is equal to x to the power of 6 over x to the power of 1 over 6. And again, this is going to equal x to the power of 6 over x times 1 over 6. These two cancel out. So now I'm left with 9 to the power of 1 over x is equal to x to the power of 1 over x. Now, 9 is the same thing as 3 squared, so I get 3 squared to the power of 1 over 6 is equal to x to the power of 1 over x. 2 and 6, these make 3, so I get 3 to the power of 1/3 is equal to x to the power of 1 over x. And notice how this is in the form x to the power of 1 over x. A number to the power of 1 over that same number is equal to x to the power of 1 over x, meaning x is simply equal to 3. So now to check, my original equation was 9 to the power of x equals x to the power of 6. So I get 9 to the power of 3 is equal to 3 to the power of 6. And 9 is the same thing as 3 squared, so I get 3 squared to the power of 3 is equal to 3 to the power of 6, which is 3 to the power of 6 is equal to 3 to the power of 6.